Okay, so I'm going to cover the bit of the pack on roots of quartic equations in this video. It's basically just exactly the same as we've been doing for quadratics and for cubics, but more long-winded. Okay, so please use these videos or this video to work through this part of the pack yourself, and then in lesson we'll get on to some more exam-style questions and some trickier things. Okay. I'm not going to prove where all these results come from. We did it for quadratics. It's doable for cubics. It's just long for quartics. So you can have a look in the textbook if you really are interested. But here are the results for quartic equations that you need to learn. And these results are summarised on the front of your pack. So if you ever need them, you can just quickly refer to them there. As always, the sum of the roots of a quartic equation is equal to minus b over a. This is true for any polynomial. The sum of the product pairs is the same as for cubics. So sum of the product pairs is equal to c over a, and there are 6 different product pairs you can have. So if you've got roots alpha, beta, gamma, delta, there are 6 combinations of product pairs that you can have. For the sum of the product triples, this is the same as the product of the roots of a cubic. That result is equal to minus d over a. There are 4 combinations for that. And the product of all 4 of the roots of a quartic is equal to e over a. So notice the repeating patterns of b over a, c over a, d over a, e over a, and the alternating sign patterns of minus, plus, minus, plus. Should hopefully make this not too bad a thing to remember. But you do need to learn these results. They're not on the formula sheet. So for this first example here, and what I'm going to do is just work through the examples. You can pause the video and give yourself time to do the u-tries at the same time. I'll just work through these. So for this one here, we've got a quartic equation. The first thing asks us for the sum of the roots, which is always equal to minus b over a. In this case, b is 3 and a is 2, so this is equal to minus 3 over 2. The next one is the sum of the product pairs. That's equal to positive c over a. C in this case is minus 7 and a is 2. The sum of the product triples is equal to minus d over a. D is 4, so this is equal to minus 4 over 2, which is minus 2. And finally, the product of the roots is equal to positive e over a. E is 10, a is 2, so that's equal to 5. So pause the video now, have a go at the u-try, and then I'll reveal the answer for you in a couple of seconds. Okay, so you can pause it again and mark that easy. Just like we've done for quadratics and for cubics, given the roots of an equation, you can work out the coefficients of the original equation. There's a couple of ways to do it. You could do this in brackets and expand it all out, or you can do it using the sums and products of roots. It is long, but we'll deal with it. Okay, so our roots are 2, minus 3, and minus 1 plus or minus root 3. Let's start off with the sum of the roots. So if we add these together, I've got 2 plus minus 3 plus minus 1 plus root 3 plus minus 1 minus root 3. Root 3's cancel out, and that will give you minus 3, which is equal to minus b over a. And we'll come back to that. Next is the sum of the product pairs. So pairing these up, I can have 2 times minus 3 plus 2 times 1 minus 1 plus root 3 plus 2 times minus 1 minus root 3. So that's 2 paired up with all of those. Pair of the remaining ones is minus 3, so plus minus 3 times minus 1 plus root 3 plus minus 3 times minus 1 minus root 3. And then the last one is pairing up the 2 thirds. Okay, so you can type all that into your calculator if you like, do the individual calculations. I think I'm probably faster doing this by hand. So that will give you minus 6, minus 2, plus 2 root 3, minus 2 root 3. So those cancel out. Plus 3, minus 3 root 3, plus 3 root 3. Again, those two cancel out. And then at the bottom here, I've got plus 1 plus root 3 minus root 3 and then minus 3. Be careful when you do root 3 times root 3, it's 3, not 9. It's an easy mistake to make. And again, those root 3s have cancelled out. Collecting all of these up, so minus 6 minus 2 is minus 8, minus 2 is minus 10, plus 3 gives you minus 4. Plus 1 is minus 3, minus another 3 gives me minus 6, and that is equal to C over A. You can use your calculator for that. On to the sum of the product triples. So I can have possibilities for that. 2 times minus 3 times minus 1 plus root 3. Then plus 2 times minus 3 times minus 1 minus root 3. Plus 2 times, not with the minus 3 now, so minus 1 plus root 3. Minus 1 minus root 3. And then the final one is the one without the 2, so that's minus 3 times minus 1 minus root 3 times minus 1 plus root 3. Again, I'm going to expand these out. You can type it in your calculator, you can do it by hand. So this first one, got minus 6 on the outside and then expand that in. So using positive 6 minus 6 root 3. Same on the second term, so we've got minus 6 on the outside, will give me positive 6 plus 6 root 3, and again, those root 3s will cancel. Now here, I've done this before. I've done this in the previous one, so that was the final 4 terms of this, and I ended up with minus 2 when I did that. So this is the same as 2 times minus 2, minus 4. And again, I've got it here. And I got minus 2 before, so minus 3 times minus 2 gives me plus 6. So overall, this gives me 6 plus 6 plus 6 minus 4, so it gives me 14, which is equal to minus D over A. Lastly, I've got the product of the roots, so alpha, beta, gamma, delta. This is 2 times minus 3 times minus 1 plus root 3 minus 1. Minus root 3, so this is minus 6 times minus 2, which gives me positive 12, and that's equal to E over A. We can now pick a value for A and then work out all the rest of these coefficients. So none of these are fractions, so it makes sense to choose A to be 1. In that case, B must be equal to 3. C must be equal to minus 6. D must be equal to minus 14. And E must be equal to 12. And that's all the question asks. Okay. So again, there is a question for you. You can pause the video and have a work through the question for you, and then I'll reveal the answer in a couple of seconds. Okay, so pause it again and double check your answers. So this exercise 4A here, to get a bit of practice on this, you can alternate these questions. So I'd say do 1A, C and E, 2A and C, I've got 3 and 4, they're a bit more interesting. We can do all of this stuff with complex solutions as well. So remember, with quadratic equations, you either get 2 real solutions or 2 complex solutions. You can't have any other combinations. For cubic equations, you can have 3 real solutions, or you can have 1 real solution and a complex conjugate pair of solutions. For quartic equations, there are 3 options. So all 4 of your solutions can be real. You can have 2 of them real and 2 of them in a conjugate pair, or you can have all 4 of them being complex, made up of 2 conjugate pairs. That's as long as your coefficients are real, which they always will be. So here we've got a quartic equation that we're given 1 root of, and we're going to solve this. I'm going to show you 2 methods for doing this. It's entirely up to you which method you prefer. So this first one, we've been given that 1 root is 2 plus I, which means we can immediately write down that one of the other roots is the complex conjugate of that, which is 2 minus I. From this, we can work out a quadratic equation which will factorize into this quartic. So I'm going to do that using the sum and product of the roots. So the sum of the roots here is 4, which is equal to minus b over a. And the product of the roots here is 2 plus I, 2 minus I. Which, if you expand that out, that gives me 4 minus 2i plus 2i minus I squared. So that gives me 5, and that's equal to c over a. If I choose a to be 1, I get a quadratic equation. So a equals 1, b equals minus 4, and c equals 5. So z squared minus 4z plus 5. Okay, that's a quadratic equation with the roots alpha and beta. And I know that this will be a factor of that quartic. So what I'm going to do now is I'm going to factorize the quartic equation into this quadratic and another quadratic in that bracket. Now you can use whatever method of division you prefer. If you really want to do long division, you can do. If you want to do a reverse grid method, you can do. I'm going to use inspection because it's fast, but it's entirely up to you. So given that one of the brackets is z squared minus 4z plus 5, first thing we can do is work out what goes in the front of the other bracket. So to get 2z to the 4, I've got to times z squared by 2z squared. As a consequence, that gives me 2z squared times the minus 4z, so that gives me minus 8z cubed already. I only want it to be minus 3z cubed, so I need to add an extra 5z cubed, which I'm going to get from doing 5z times the existing z squared on here. Okay. As a consequence of that, I'll get 5z times minus 4z, which will give me minus 20z squared. Sorry, no, I'm not going to do that. The easiest way to finish this off then is to look at the number term. So the number term is minus 15. I've got plus 5 in here already, so I know that if this factorizes, it has to be minus 3. Okay. And you can double check that this is correct by expanding all of this out. But it is correct. Once we've got this other quadratic, we just need to solve this equal to 0 as well, and then that will give us our remaining 2 roots. 2z squared plus 5z minus 3 equals 0. You can solve it on the calculator. You can use quadratic formula, you complete the square, anything is fine in this case. So I'm going to complete the square on this one just to get a bit of practice. Take out the 2. I'm going to add the 3 across. Now let's complete the square first. Actually. So we've got z plus 5 over 4 squared minus 25 over 16 minus 3 equals 0. So I've half the z coefficient and got 5 over 4, squared that to get 25 over 16 and took it away. Let's expand this all out. So we've got 2 z plus 5 over 4 squared minus 25 over 8 minus 3 equals 0. Which gives me minus 49 over 8. We'll take the 49 over 8 across and divide through by 2. Which ends up being positive. So when we square root this, we're going to get plus or minus 7 over 4. I'm going to get 2 real roots. So if I minus the 5 over 4 across, this either gives me a half. If I do minus 5 over 4 plus 7 over 4, or it gives me minus 3. Okay, so in this case, our quartic has 2 real roots and 2 complex roots which form a conjugate pair. Pause the video now, have a go at this question for you here, and then in a few seconds I'll reveal the answer. So now you can pause it and double check your answer. Oh, I completed the square. I could have just factorized that. Yeah. Okay. An alternative method is this. So we start off the same way. So say one of the roots is 2 plus I. One of the other roots must be 2 minus I. And then we can use what we know about sums and products of roots for the whole equation for the quartic. Okay, so we start off by looking at the sum of the roots. So that's 2 plus I, plus 2 minus I, plus 2 other roots, so plus gamma and plus delta. And we know that's equal to minus b over a. The i's cancel out, so this gives you 4 plus gamma plus delta, and that's equal to minus b over a. Well, b is minus 3, and a is 2, so that gives me 3 over 2. And that gives me an equation for gamma and delta. Minus that 4 across to get minus 5 over 2. I can use one of my other bits of information. The easiest one to do, I think, is alpha, beta, gamma, delta. So the product of the roots, rather than doing multiples of the sums and product pairs and product triples and stuff. So the product of the roots is 2 plus I times 2 minus I times gamma times delta, and that is equal to E over A for a quartic. If I expand this bracket out, it gives me 4 minus 2I plus 2I minus S squared. Gamma delta. And E over A, in this case, E is minus 15, and A is 2. So that gives me 5 gamma delta equals minus 15 over 2, or I can divide through by 5. To get gamma delta is minus 3 over 2. Notice what we've got here. We've got a pair of simultaneous equations. Now, unfortunately, they're not linear, so I can't solve them in the calculator, but it's not too bad to solve them by hand. So if I rearrange this one by dividing through by delta or gamma, doesn't really matter. So I get minus 3 over 2 delta, and then I'm going to sub this one into equation 1. So I've got minus 3 over 2 delta plus delta equals minus 5 over 2. This is an equation that I can solve to calculate delta. I'm going to times through by 2 delta because there's 2's on the fractions that I don't like. So this will give me minus 3 plus 2 delta squared, and that equals minus 5 delta. This is a quadratic in delta. So 2 delta squared plus 5 delta minus 3, which you can solve on the calculator. You can factorize this rather than completing the square. So we've got 2 delta, it's rubbish delta, let's try that again. 2 delta, delta. I need 3 and 1 in here, so 3 goes in here, 1 goes in here. Does it? Sorry, no, it doesn't. 3 goes in here, and 1 goes in here. And that gives me 2 solutions. I either get delta is a half, or delta is minus 3. That's what we got, which is what we got in the previous one. You can go back and work out gamma, but it will just be the other one, the alternate one from these. So these are your other 2 roots. So it doesn't matter what pair you pick. Let's just check. So if delta is a half, gamma equals minus 3 over 2 delta. Well, if delta equals a half, that's minus 3. And if delta equals minus 3, that's equal to a half. So minus 3 seconds. Okay, so it doesn't matter which is which. So just pick equivalent, so choose gamma equals a half. Delta equals minus 3. I've got the same you try but using this method, so pause it. And then in a couple of seconds I will reveal the answer. You can pause this again to have a quick check of your answer. It doesn't quite fit on one page. I've got a preference, and you've probably got a preference. Method 1 is much shorter, much more concise, so I prefer that. Should get the same results as you got in the first. One final example. It's this one. So we've got a quartic, but it's missing a couple of coefficients. So, it wants us to write this as a product of two quadratic factors without actually working out p and r, which we can do. So if one of the roots is 1 minus 3i, we can immediately write down that one of the other roots must be the complex conjugate as 1 plus 3i. We can work out the quadratic from this. So the sum of these roots is just 2, so the i's cancel. And that's equal to minus b over a by quadratic. And the product of these roots, let's expand this bracket, gives me 1 plus 3i minus 3i minus 9i squared. The i's cancel out. I squared is minus 1, so this gives me 10. This is equal to c over a. If we choose a to be 1, that means that b must be minus 2 and c must be 10. So the quadratic corresponding to these two roots is z squared minus 2z plus 10. That means this is one of the brackets for our quartic, and then you can use whatever method of division you prefer, long division, reverse grid method, or inspection, whatever, to work out what the other quadratic will be. So first off, the first term must be z squared, because in the original quartic that's a z to the 4. Then looking at the z cubed term, so I need minus 2z cubed. Well, I already get that from doing this, so doing z squared times minus 2z. So I don't need another z term to get any more cubic terms, so I'm going to put plus 0z in here. I don't have p and r, but that doesn't matter. I just need to look at the final number term and say, what do I need to times 10 by to get 80? So that must be 18. Okay. You don't have to write the plus 0z, it's just really for demonstration purposes. Finally, to work out p and r, the best way to do it is expand this out again. There are other ways, but the best way to do it is expand this out. So I'll get z squared times z squared z to the 4 plus 8z squared minus 2z cubed minus 16z plus 10z squared plus 8. Collect all like terms, so z to the 4 minus 2z cubed. Use that one and that one. There are 2z squared terms, that's plus 18z squared. There's only one z term, so minus 16z. And plus 18. So that tells us that p must be equal to 18 and r must be equal to minus 16. Okay, so I've gone through that fairly quickly. In any of these examples, if you need to pause it and go back over it or watch it at half speed or whatever, go for it. There's a final question for you here, so have a go at this question for you. Pause the video while you're doing that, and then I'll reveal the answer in a couple of seconds. So again, you might want to pause the video, double check your answer, and see if you got this right.